Hi everyone, I am Laurice Angeles, third year BS Chemistry student, and I am from UP Materials Science Society. In this Chem 31 review video, we will once again be tackling organic chemistry topics. Excited na ba kayo? Excited na ba kayo matapos ang SEM? Kasi same! So for this last video, for your last Chem 31 LE, we will be answering and discussing some practice questions and problems on aldehydes and ketones. Before we start with that, let us first recall what aldehydes and ketones are. The general form for aldehyde is RC double bond OH, and the general form for ketone is RC double bond OR. So, R usually represents an alkyl group, but in this case, it can also represent an aromatic. So the functional group for this is called the carbonyl group, which is the carbon-oxygen double bond here. That is called the carbonyl group. An example of an aldehyde is formaldehyde, and it looks like this. HC double bond OH. It is the simplest aldehyde, which is called formaldehyde. Formaldehyde is the common name, and the IUPAC name is methanol. And an example of a ketone is the acetone, and it looks like this. CH3, C double bond O, CH3, and this is called the acetone. Acetone is the common name, and the IUPAC name is 2-propanone. The first problem, select which is more reactive towards the nucleophile. So, pagdating sa reactivity of our aldehydes and ketones, we have general rules. So, aliphatic aldehydes are more active than aliphatic ketones. So, general rule yan. And then also, aliphatic aldehydes and ketones in general are more reactive than the aromatic aldehydes and ketones. So, these will be our general rules. So, pagdating ito sa number 1, we see that both are aldehydes kasi may H na naka-attach doon sa carbonyl carbon. So, ang titingnan lang natin which one is aliphatic and which one is aromatic. So, clearly, this compound here is the aromatic aldehyde. So, automatically, this one will be less reactive than this one. So, our answer for this item is formaldehyde. This one is more reactive towards the nucleophile. Number 2, we both have aromatic aldehydes kasi again, we have an H attached to the carbonyl carbon in both compounds, and we also have aromatic groups also in both compounds. So, ano yung magiging deciding factor natin dito since both are aromatic aldehydes? So, if we notice, the first compound, actually yung difference lang talaga ng compounds ay yung NH2 group here. So, if we notice, the NH2 group here, it has a free electron. So, what does it mean if it has a free electron? It means it is an electron donating group. So, dahil meron tayong electron donating group dito, the electron density of the entire molecule will increase. And when the electron density of the entire molecule increases, it makes the nucleophile stronger. So, nagiging mas reactive yung nucleophile natin kapag merong electron-donating group. So, comparing the two, obviously, the first compound will be more reactive sa nucleophile because of the electron-donating group. Okay, so this is number 3. I forgot to mention pala that you can pause the video before you answer each item if you want to answer them first on your own. So, okay. We have here an aromatic aldehyde and we have over here an aromatic ketone. So, this is an aldehyde kasi there is a hydrogen attached to the carbonyl carbon here. Tapos, dito naman sa kabila, we have a ketone kasi meron tayong walang hydrogen na nakatouch sa carbonyl carbon and we have here an alkyl group lang and an aromatic sa other side. So, it's a ketone. So, again, general rule natin, aldehydes are more reactive than ketones. So, automatic, itong aldehyde natin dito will be more reactive towards the nucleophile. Easy peasy. Next problem, predict the products of the following acetal formation reactions. So for number 1, our acetal formation reaction is acetone reacted with 2 moles of methanol in HCl. So the mechanism for this is quite long, but our final answer is this. OCH3 CH3 OCH3 CH3. So this is our final answer for this number 1. But of course, I will show the mechanism. So buburahin ko muna itong final answer natin. Basta yan yung final answer natin. And you will find out how we got that answer. So the reaction starts with reaction of acetone with the proton from HCl. Like that. So, it will become like this. OH plus CH3. And this is in resonance with CH3, COH, CH3 plus. So, this resonance structure, pwede na siyang reactan ng first mole of methanol natin. So, I will go to the next page, pero katuloy lang yan din. So, we will have CH3, COH, CH3, OCH3 plus H. Ito yung nanggaling sa methanol natin. And then, it will eventually become a hemiacetal after the proton here will dissociate. So, we have CH3, COH, CH3, OCH3 plus the proton na natanggal. And then, we will have CH3, OH2 plus CH3, OCH3, wait nga. So, if we notice, yung proton here, nag-bind siya dito sa oxygen here. So, we have OH2 plus. And then, with the movement of electrons from here to here, and then here to here, magbe-break yung bond dito. And then, magre-release tayo ng H2O from here. So, next page, we will have this. CH3, CH3, double bond, O, CH3 plus. Ngayon, this one, if you will notice, can also have a resonance structure. And it is in resonance with this. Nandito na yung positive charge natin. CH3, O, CH3. And then, darating na yung second mole of methanol. And it will attach, syempre, dun again sa may carbon ion natin. So, we will have CH3, CO, CH3 plus, galing dun sa methanol, CH3, CH3. And then, finally, we will have the final product. So, yun lang naman yung mechanism. Medyo mahaba lang, pero doable naman. So, correction pala, OCH3 pala ito. OCH3. And then, I said this is a carbon ion, carbocation pala yan. Ito. Okay. Next, acetal formation reaction. We have acetone reacted with ethylene glycol in HCl. So, the final answer for this one ay isang ketal. It looks like this. Ganyan. Tapos, CH3. CH3 dito. And then, CH3 here. So, this is a ketal. So, the mechanism is the same lang dun sa una. But, syempre, papakita pa rin natin. So, una, iba lang yung itsura niya dito. Pero, pwede pa rin natin siyang rewrite this way. Acetone pa rin naman yan. Reacted with, again, the proton. Will become this one. This resonance structure. Ayan. CH3. C. So, pareho lang actually yung first part pala, no? Kasi acetone din. So, resonance structure natin. I will go to the next page. The resonance structure will react with yung ethylene glycol natin. So, isang mole lang pala to ng ethylene glycol, no? Pero kasi you will notice na dalawa yung OH groups. So, we don't need 2 moles. So, yung magiging itsura niyan ay ganito. OH, CH3, attach yung buong ethylene glycol. CH2, CH2, OH, plus, tapos nandito yung H. Tapos, matatanggal ulit itong proton na to. So, ganito na yung itsura niya. Wait lang. Ayan, ganyan. From here, magiging ganito yung itsura niya. CH3, COH, CH3, O, CH2, CH2, OH, plus yung proton. Okay, I will go to the next page. Ang mangyayari dyan, again, yung proton pupunta dito. So, OH2 plus, CH3, and then, nandito pa rin yung O, CH2, CH2, OH. So, again, with the flow of electrons from here to here, mabibreak yung bond. Magre-release ulit tayo ng H2O. And then, magiging ganito na yung itsura niya. CH3, O, CH2, CH2, OH. Tapos, double bond pala ito. Tapos, plus dito. Resonance structure naman siya with this one. With this carbocation. O, CH2, CH2, OH. So, ngayon, dito dapat i-enter yung second mole of alcohol natin. Pero dahil we have here a diol, yung yung oxygen, yung OH group dito, siya yung mag-a-attack here sa carbocation natin. So, we will have this. Wait lang. So, we will have this, medyo complicated. So, I will draw it muna this way. CH2, CH2O. Yan, tapos, nandito yung H+. So, ito yung acetone natin kanina na na-attach yung ethylene glycol dito. And then, yung other side ng ethylene glycol, which is this one, ay nag-attach naman dito rin sa same carbon na ito. So, kaya tayo nagkaroon ng parang ring dito. Ito yung ring. Ayan. And then, magtatanggal ulit itong proton na to, magiging ganito na itsura niya. Mas maganda na. O, CH2, CH2O. Yan. Plus the proton. So, you can rewrite this compound this way para katulad ng pinakita ko ng una, para mas malinis. Tada! So, you can either have it written this way or this way. Tama naman pareho. So, that is your final answer. Okay, next problem, draw the structures of the final product for the following reactions. So, number 1, we have a reaction with HCN. So, automatically, we can say na this is a cyanohydrin. Cyanohydrin formation. Ang cyanohydrin formation is simply the addition of HCN. So, obvious na yan. This is a cyanohydrin formation. Yung mechanism niya, very easy and fast. So, yung CN ion natin will attack this carbon. Yung aldehyde carbon. And then, mag-yield siya with this O negative. Tapos, yung CN dito. And then, lagyan mo lang siya ng proton. And then, mag-attach siya dito. So, magiging ganyan. So, this is our final answer. Easy lang. Number 2 is also an addition of HCN. So, automatic cyanohydrin formation din ito. Following the mechanism from number 1, we have CN ion will attack here. Tapos, it will yield this compound. Same lang. But with O negative here and then CN attached here. And then H plus, and then we will have this final product. Para lang ma-hydrolyze yung oxygen here. This is your final answer. Cyanohydrin formation. For the next 3 items or so, we will have reactions with Cyclopentanone with different reagents. For this one, we have ethylene glycol. Again, same sa mga previous items na sinagutan natin, this will be acetal formation. And the final product for this one is this. It looks kind of familiar kasi same siya doon sa, it looks the same doon sa previous item na sinagutan natin, but slightly different. So, yung mechanism starts with the cyclopentanone reacting with the proton. Tapos, you will have the resonance structure, OH plus. This is in resonance with this. Tapos, dito yung charge. Ay, dito na lang. Yan. And then, magre-react na siya with the ethylene glycol. This will attack here, doon. And we will have this. OH, tapos, andito yung ethylene glycol. H plus. Tapos, matatanggal itong proton dito. So, it will become like this. OH. Tapos, plus H. Yung natanggal na proton. And then, mag-attach ulit siya doon sa compound. Pupunta siya dito, OH2 plus OH. So, ngayon, with the flow of electrons, magiging ganyan. And then, this bond will break, leaving us with an H2O na na-release. And it will look like this. Ayan, tama. Ayan, kasi natanggal na yung H2O doon sa taas. So, naiwan tayo. Ito yung galing sa ethylene glycol. Ngayon, this is in resonance then with this structure. Teka lang. Yan. And the charge is here. Tapos, itong other end of the ethylene glycol will react doon sa carbon na yan. And we will have this. Yung medyo kamukha na niya yung final product. Pero may H pa dyan. Plus. Tapos, finally, matatanggal din yung proton. We will have this. Ayan. And this is your final product. Number 4, cyclopentanone ulit with reaction with HCN. So, automatic reaction na may addition of HCN. We call it a cyanohydrin formation. At ang final product nitong cyanohydrin formation reaction ay ito. OH with CN here. Mechanism, very simple. We start with the cyclopentanone at mag-a-attack ang ion na ito doon sa carbon na yon. and we will have this O negative with Cn attached. Tapos, hydrolyze lang natin, and we will have the final product, OHCN. Yan. Next item, we have Cyclopentanone ulit, pero this time 2 moles naman ng methanol in acidic medium. So, same lang to dun sa mga previous items na napakita ko. So, alam nyo na yon. Ito yung final product. OCH2, CH2, I3, and then OCH2, CH3, acetal formation. Perfect, yun na yan. Moving on to our next problem, draw the enol form of the following compound. So, we have here an acetal acetone. So, meron tayong tinatawag na keto-enol tautomerization. Hindi ko alam if it's tautomerism or tautomerization dahil nakalagay sa notes ko, it's tautomerization according to my prof. It's tautomerization, but when I search sa internet, it's tautomerism. So, I guess it's the same. Basta, keto-enol. So, the simplest example for keto-enol tautomerization ay itong acetone. Tapos, pwede siyang ma-interconvert into an enol form. CH2, double bond, OH. So, if you notice, ang nangyari lang, papalitan lang natin itong oxygen dito with an OH group at ililipat natin yung double bond dito mula sa carbonyl compound sa either left or right nitong bagong enol form natin. So, in this case, it doesn't matter if sa left or sa right yung double bond natin since meron naman siyang symmetry dito. But of course, for example, dito sa number 1 natin, meron tayong acetal acetone. Nagmamatter kung saan natin ilalagay yung double bonds, kung sa left ba or sa right. So, let's discuss that further. So, dito nga sa case ng acetal acetone, i-rewrite lang natin ulit. Subukan natin to convert it into an enol form. So, shortcut, papalitan lang natin yung isang oxygen dito sa carbonyl group into an OH group. So, try natin yun. Doesn't matter naman which oxygen yung papalitan mo. Basta isa lang. So, palitan natin yung second oxygen na carbonyl group ng OH. Tapos, ililipat natin yung double bond either sa left or sa right. So, try natin to put it dito muna sa right. So, that means magiging CH2 ito. And then, let's also look at the form if dito naman natin sa right ilalagay. CH, double bond C, OH, tapos CH3 dito. So, looking at this, syempre, looking at both forms, titingnan natin which is more stable. So, according to the Saint-Zeph rule, if you remember, I discussed it in the first set of videos for Chem 31 review. Ang Saint-Zeph rule, sinasabi doon na mas stable ang alkene kapag mas maraming alkyl groups ang naka-attach doon sa double bond. So, check natin itong first compound. Ito yung, kita natin yung, wait, let's change color. Kita natin yung double bond dito. At nakita natin na may dalawang hydrogen na naka-attach dito sa carbon na to, at sa kabila naman may OH group at merong namang CH2. So, makita natin na dalawang alkyl group ang naka-attach sa double bond. Dito naman sa second natin na enol form, ito yung double bond, and we can see na isa lang yung H na naka-attach doon sa double bond. So, meron siyang tatlong alkyl groups na naka-attach sa double bond. So, according to Saint-Jeph rule, itong second form natin ang mas stable dahil mas marami siyang alkyl group na naka-attach sa double bond kaysa dito sa first one natin. So, ang ating final answer for this keto-enol, for the enol form of acetylacetone ay this one. Itong enol na ito. So, for further discussion of keto-enol tautomerization, its mechanism kasi can either be catalyzed by acid or by base. And I want to show you the mechanism for both acid-catalyzed and base-catalyzed keto-enol tautomerization. So, yung una kong ipapakita ay yung sa acid-catalyzed. So, here, magsisimula tayo sa acetylacetone. So, syempre, dahil acid-catalyzed, it is in acidic media. Tapos ngayon, magre-react itong acetylacetone natin sa proton na yan. At magiging ganito yung itsura niya. OH plus CH3. Ngayon, gusto ko lang i-emphasize itong hydrogen dito. Ayan. Dahil itong hydrogen na to, mag-attack siya here, at yung electrons from here will go to here. At ang maging itsura niyan ay ganito. Ay, mali. So, yung double bond nga ay nandoon sa gitna. Ayan. Ngayon, i-hydrolyze lang natin. Ay, hindi pala. H na pala yan. So, yun. Ma-hydrolyze na siya. At ito yung final answer natin. Galing doon sa mechanism na pinakita ko. Moving on to the base-catalyzed keto-enol tautomerization mechanism. So, meron ulit tayo dito yung acetylacetone. Tapos, dahil base-catalyzed nga, OH na nandito. So, let me just emphasize yung hydrogen dito. Dahil itong OH na to, it will attack this hydrogen. And the electrons will move from here to here. Ayan. At ang magiging itsura niyan ay carbon ion. We will have a carbon ion here. Negative charge yan. Ito. Ngayon, this will attack this at yung flow electrons. Oops. Ganun ulit. At makikita natin that this is in resonance with this structure. Oops, wait, mali. CH3, double bond O, CH, 2, C, yan. They are in resonance, plus H, ay mali, wala palang plus H. At ang ma-hydrolyze lang siya ng water. Wala nang space dito. So, basta kapag na-hydrolyze siya ng water, ang itsura niya, magkakaroon niya ng H. So, ito na yung keto-enol, ay yung enol form ng acetal na makita naman natin it's the same lang doon sa acid catalyzed. Pareho lang yung enol form but iba lang yung mechanism. But the final answer is the same. For number 2, we have this compound. So, draw the enol form of this compound. So, again, shortcut. Alam naman na natin yung mechanism. I just discussed it. So, yung shortcut, yung oxygen dito, papalitan lang natin ng OH group. Yan. And then, pipili tayo kung which side natin ililipat yung double bond, dito ba sa left side or sa right side. And according again to Saint-Zeph rule, mas stable ang alkene if it has more alkyl groups attached to the double bond. So, clearly, dito sa left natin, dapat ilagay yung double bond. Dahil mas konti lang, mas marami yung alkyl groups na naka-attach sa double bond if dito natin ilalagay yung double bond. Rather than if ilagay natin siya dito sa right side. So, this is our final answer. Next problem, show how the following compounds could be prepared by the Aldol condensation reactions. So, for our first compound here, meron tayong alkene. So, I think to further understand this problem, I should show you an example of a crossed aldol condensation reaction na nag-yield ng alkene. So, here is our example of an aldol condensation that yielded an alkene. So, we have here reactants, benzaldehyde, and acetone. So, makita natin that when an aldol condensation yields an alkene, ibig sabihin one of the reactants has no alpha carbon. So, looking at these two reactants, benzaldehyde and acetone, makita natin that benzaldehyde is the one na walang alpha carbon. Has no alpha carbon. Alpha carbon is the carbon right next to the carbonyl carbon. Ngayon, if you're going to see the final product, yung carbonyl carbon ng benzaldehyde, the one with no alpha C, ay mag-form ng double bond with the alpha carbon of acetone here, na yung acetone yung compound na meron namang alpha carbon. So, ayan, makikita natin dito na yung carbonyl carbon ng benzaldehyde nag-form ng bond with the alpha carbon of acetone. Ngayon, with further into the reaction, makita natin na na-form na nga yung double bond nila. So, easy na yan. We can now answer the problem here, which is kahanapin natin yung reactants that formed this alkene over here through aldol condensation. Now, pwede na natin sagutan itong problem na to. So, dahil nga alam natin na nagfo-form yung bond between the two compounds doon sa double bond, pwede natin hatiin yung compound like that para ma-distinguish natin yung dalawang reactants. So, obviously, since ito yung side na merong carbonyl compound, ito yung compound na merong alpha carbon. And we will just write it this way. So, it's an aldehyde dahil may H bond dito. Tapos, CH2, CH2, tapos tatlong CH2 yan. And then, CH3. So, ito yung first nating reactant. Tapos, dito naman sa side na to, dahil siya yung walang carbonyl compound, alam natin na etong C-carbon na ito na naka-attach dun sa other side with the double bond, siya yung carbonyl compound originally. So, it will look like this. It is also an aldehyde kasi may H. Tapos, CH2, apat na CH2, CH3. Okay, medyo nagdikit sila. Pero wait nga. Medyo nagdikit sila pero ito yung second natin na reactant, tapos ito yung first. Or basta yan yung dalawa. Ayan. Yan yung final answer natin. Pakita lang natin yung mechanism nung aldol condensation na yun. So, nakita natin, pareho lang yung lumabas na reactants. Identical siya. So, ayan. Ang magiging mechanism nito, so magpo-proceed yan. At maggagawa na sila kaagad ng bond. 4CH. Tapos, andyan pa yung OH group. CH, oops, C double bond O, H, tapos naka-attach dito yung tatlong CH2, CH3. And then, magpo-proceed lang ulit yung reaction. And makuha na natin yung final product. There. That is how this alkene was yielded gamit ang crossed aldol condensation. For number 2, same instruction, show how the following compound could be prepared by the aldol condensation reactions. So, meron ulit tayong alkene, so same. Hatiin natin yung compound dito sa gitna. And then, dahil nakita natin na nandito yung carbonyl compound, yung carbonyl carbon pala, alam natin na dito sa side na to, itong C na to na naka-attach doon sa other side with the double bond ay yung original na carbonyl compound. Carbonyl carbon originally. So, let's rewrite those into two reactants. So, yung first one, ito na yung carbonyl carbon, H. And then, ito naman, rewrite natin siya this way. Yan. Both are aldehydes. And then, yung reaction, magpo-proceed lang ulit this way. Naka-attach na kaagad doon. And then mag-proceed lang ulit further. And we now have the product. There. Number 3, meron ulit tayong alkene. So, again, you will try to divide the compound dito sa may double bond. And dito naman sa right side, nakita natin, wala siyang carbonyl carbon. So, we know that itong carbon right here, siya yung original na carbonyl carbon doon sa reactants ng aldol condensation. So, let's write it this way. It is a Cyclopentanone. Tapos, dito naman sa other side, alam natin na ito yung alpha carbon at ito yung carbonyl carbon. So we will just write it this way. They are both cyclopentanones. Tapos, mag-proceed lang ulit yung reaction. And it will look something like this. So, ito yung unang cyclopentanone. Nag-attach yung other cyclopentanone doon sa alpha carbon. At merong OH here. Tama ba? Tama. Ngayon, mag-proceed lang ulit yung reaction. And magkakaroon na siya ng double bond. And we have here another alkene. So, ayan, yan lang yung mechanism ng crossed aldol condensation when one of the reactants, or at least one of the reactants, doesn't have a carbonyl carbon. I mean an alpha carbon pala. You have reached the end of this video. Thank you very much for watching. And good luck sa exam nyo. Congrats dahil last exam nyo na, malapit na matapos ang SEM, malapit na tayo magbakasyon. So I hope and wish that you will do very well, and I hope that you'll enjoy your very well-deserved break after. Thank you and goodbye.